Okay, Year 11. So in today's lesson, we are still continuing with the topic natural hazards, and we're going to be looking at how tropical storms are formed. So in the previous lesson, we looked at where tropical storms were formed. So we're going to do that as a recap, and then we're going to look at how they're formed and the different features that a tropical storm has. Okay, so this is where it ties into the specification, which we can see here. And then we're going to be able to know by the end of the lesson how to explain how a tropical storm forms and identify parts of a tropical storm. So let's get started. This is a little recap. So what is needed for a tropical storm to form? Well, let's have a little look at what we've got here. So the first thing we needed are sea temperatures of 26.5 to 27 degrees more, and that is because we are in a close proximity to the sun, so the sun's rays are more concentrated, which is why we normally get tropical storms between 5 and 15 degrees north and south of the equator. We also needed it to be a low pressurized area, which we can see here. So a low pressurized area is when the air is able to rise, cool and condense and make clouds, and then it rains again, as we can see. So this is low pressure. Similarly, we need to have the Coriolis force, which we can see here. So the Coriolis force is to do with the way that the Earth spins. So as that warm air rises, it bends, and then that creates that spinning effect, which is what an aerial view of a tropical storm looks like. So this would be like a satellite image. So the Coriolis force allows that curving and spinning to happen, and I refer to it as being like candy floss. And then we have other things. It has to be 5 and 15 degrees north and south of the equator, which we can see in this image. The sea depth has to be at least 60 meters. And it has to happen in tropical region. So that was just a recap of the previous lesson. Okay, so what this diagram here is going to show us is the formation of a tropical storm, and you might choose as we're going through to draw something similar, but there will be an opportunity for you to do that later, so it's up to you what you do. So let's go through and look at how the tropical storm is formed. So we can see here that the sun is going to be putting its rays down onto the ground, which is going to mean that the sea temperatures are going to rise to between 26.5 and 27 degrees C. Okay, so as a result, that will create evaporation. So evaporation is when that air when water turns into a gas and it rises into the atmosphere. And as it rises further into the atmosphere, it's going to start to cool and condense. Okay, so as the air rises and cools and condenses, and the reason it rises is because it's a low pressurized area, so that's really important to remember, the rising air is going to draw in more moisture from the ocean, causing strong winds. And this all ties into the Coriolis effect and the trade winds that we were looking at when we were doing the atmospheric circulation. Now this is going to create large cumulonimbus clouds, and these are mostly associated with convectional rainfall, they're quite big, thick storm clouds that bring lots of rain and wind, and also thunder, which we get a lot of in tropical and equatorial regions. So the Coriolis effect causes the air to spin upwards. So when the air is spinning, so it's moving upwards like this, okay, but then some of that cooled air can then sink back down to create the calm center of the eye. So this area here is known as the eye, and if we looked at it from an aerial view, this section here would be the eye, which is the calm part of the storm. So that forces back down. Okay. Now what happens next is the air then, so let me just get rid of all this here. So the air then rushes in from high pressurized areas outside of the storm to low pressurized areas. So the air is rushing, this will then rush in and sink. So remember that high pressurized air sinks. Remember, in high pressurized areas, we have no clouds. So that explains why in the eye of the storm, there's no cloud cover and it's very calm. So this creates, a very calm area in the middle of the storm, which is known as the most calm and part of the storm, and suggests actually that there isn't a tropical storm occurring, which can actually be quite dangerous. Okay. All right then. So what we're going to do next is, you can see on the screen that there are 6 statements and there is a diagram. So we can see here that the arrows are showing us, the red arrows are showing us this warm air. So these are the areas, so the warm air is rising, cooling, condensing and making these large cumulonimbus clouds. And we can see in the center, the reason that it's spinning is because of the Coriolis effect. And then we have that colder air rushing in from outside of the tropical storm. So this is our high pressurized air, which is then sinking back down and creating that gap, that eye in the middle of the storm, which then allows this low pressurized air to then kind of go back in again, and then that will fuel the storm more. So I would like you to draw the diagram, please, on the board, and make sure you've included all the figures about how wide the eye can be and how wide the actual storm can be itself. And then I would like you to put these statements in order of 1 to 6. And then on the next slide, we will go through the answers. So pause the video here while you're doing this. Okay, so make sure now that we're green penning our answers to make sure they're in the correct order. So step 1, the sun warms the oceans to 27 degrees C or 26.5 degrees C, causing evaporation. Now, I would like you, every time I underline a keyword, make sure that you have defined it. This moist, warm air rises rapidly, causing low pressure conditions. So remember to remind me what low pressure means. As the air rises, it cools and condenses, and the rising air draws in more moisture from the ocean, so it's getting a constant fuel supply. So let's write that down. So it has a constant supply of water, which is essentially fueling the tropical storm. So that's going to create strong winds. The Coriolis effect causes the air to spin upwards, so we kind of get this occurring. And then some of the cooled air sinks back down to create a calm central eye. So the air sinking is associated with high pressure. So remember to define what that means. Step 5, as the air rises and condenses, it forms large cumulonimbus clouds. So making sure you know what a cumulonimbus cloud is, which causes heavy rainfall, and actually, let's go further than this, wind and thunder sometimes. Okay. And then air rushes in from high pressurized areas outside of the storm to low pressurized areas at the center of the storm, creating winds. Okay, so this is how a tropical storm forms. And step 4 and step 3 and step 6 are kind of showing us how it continues, so what is really fueling that tropical storm. And the only way the tropical storm will stop is if it hits land, because it then loses its source of energy. So make sure, please, that you've green penned your work and you've got them in the correct order. So what we're going to look at here then is the structure and features of a tropical storm. So we need to be aware that every part of the tropical storm is not the same, and the center of the tropical storm is going to be very different from the outside of the tropical storm. So I would like you, please, to draw this diagram down in your books or on paper, or take a screenshot of the slide and make sure that you have this down. So you would be expected to know that in the center, so if I draw like a satellite image of a tropical storm, okay, so this black region here is the eye wall, which we can see is mentioned here. And then in the center of that hole, that's the eye of the storm. And then it tells you what the eye of the storm is here. So make sure you've got down your definition for the eye of the storm, and make sure you've got down your definition for the eye wall. Okay. And then it tells us what the conditions are as we move away from the eye wall. So it tells us what the conditions are at the eye wall, outside of the eye wall, and then the furthest away from the eye wall. And you'll notice that this is statement 1. This statement is duplicated twice, and this statement is duplicated twice because the same thing happens on both sides of the storm. So make sure, please, you have all of this information down before you move on. So the final thing we're going to look at now is this practice question. So this question says, how might climate change affect the distribution, frequency, and intensity of the tropical storm? So we need to know what these terms mean. So climate change, we're talking about Earth getting warmer. The distribution is to do with its location. So currently we get them between 5 and 15 degrees north and south of the equator, but if the temperatures increase, could they move further from the equator? Okay. The frequency, so how often they are occurring. So remember that they need to be at least 26.5 degrees C of the oceans. If the oceans are warmer, then they may occur more often. And we can kind of see that in this figure. So we can see this blue line that the sea surface temperatures in 2010 were 28.4 degrees, which is significantly higher than they were in 1950 when it was roughly 27 degrees. So they're going to be occurring much more often, which means that the intensity of them may be much more powerful because the storm is going to have much more energy. So have a go, please, at answering this question using the figure also, and then on the next slide we will go through some answers. So pause it here, have a go at answering this question, and then make sure that you green pen your work on the next slide. Okay, so here are some statements that you could have said. So make sure you pause it here, green pen and prove your work, and then that's it for this lesson.